we'll get started. And just to address, this is my daughter Eva. She is 5, and there's no school today, and couldn't find a babysitter in time. So anyway, she'll be joining us, and we have that. Okay. All right. Well, let's continue in our discussion of visualization and Ggplot. And here I was just going to show you how to do some stuff. And in particular, I wanted to do bar plots, and if we have time, we'll get I'll introduce line plots as well. Okay. How's homework 1 coming along for everybody? We're good. We'll be able to turn everything in on Friday. Okay, and then data camp. I saw some questions. Yes, I did assign some data camp chapters this week, and my estimate is it would take somewhere between an hour and a half to do all 4 chapters.
Yeah, it wasn't as long.
Okay, if I try to go through them myself and try to see how long it takes, and if my estimates of time are out of touch with reality and whatnot, let me know. Okay. As far as data camp, my goal is no more than 2 hours in a week or something for data camp homework. So my target's probably hour and a half. There might be some weeks where it's a little bit longer, some weeks where it's less. But yeah, that's as far as data camp. That's kind of the idea. The regular kind of homework that you get assigned will probably take significantly longer than the data camp, but that's the intention there. But okay, yeah. If again, there's kind of a push and a pull between myself and you as the students, and so if things are going well or not going well, you let me know. All right. Just a few friendly reminders. Number 1, make sure you're reading the textbook, okay? Make sure you're reading the textbook. It is available to read for free, okay? Modern Data Science with R, and this you can read it in your browser. If you want to purchase the textbook, you can. For homework 1, you should be reading chapters 2 and 3. And I recommend that you start chapter 4. Next week we'll be delving into, or probably even later this week, we'll get into data wrangling. And so anyway, do that. I see some kind of duplicate questions on CampusWire. So when you go on CampusWire, just do a quick search. And just so we're not asking the same questions over and over again.
I think when you're typing out your question, it also shows you.
It shows you similar
keywords
from your subject line, right?
Mm-hmm.
Yeah. Okay. And then do your data camp homework. Okay. All right. We'll want to address some more different geometries that we've seen. So. We've a lot of our things have been about geom point, and your data camp homework this week. You do a lot of stuff with geom point, and I think you alter this color and the size and the things like that. There's a couple other things that you can do, but as far as geom points go, the X position, the Y position, its color, its shape, and maybe its size we would do. Other geometries, and today the geometry I want to look at is kind of the column or the bar, and we'll look at that. And there's lots of different geometries that are available, and certainly I'm not going to have time to cover all of them. So I wanted to kind of point out, the ones that I thought were kind of most significant and most important, being the kind of the points and the columns. But there's a whole bunch of others, and please familiarize yourself with being able to read the help files, okay? And almost all of these things, you know, like if you go to GeoPoint, they all have examples showing, you know, some of the different aesthetics that they mapped to the thing, right? So over here, they created a setting called alpha. Alpha is kind of how dark the point is, so that, you know, areas where they overlap, okay, you can see, you know, there's like transparency, right, where they stack on top of each other, and you have different options as well. Okay, so here I want to look at the bar plot, and over here, basically I've got a categorical variable in one column, and here I just have control, treatment 1, treatment 2, and then in the other column I have the height, or basically our numeric variable, and we're going to plot the height of that bar using this numeric variable. Okay, so this is my data frame, 3 rows, 2 columns, and I'm going to use Ggplot with geom_col. Okay, call for the column geometric object, and this is it. Okay, so I do Ggplot. I name the data frame. I'm going to say x is the grouping variable, which is basically which category it's in. So it puts control, treatment 1, treatment 2 along the x-axis, and then the height of the bar, which is, you know, 5.0, 4.6, and 5.5, is going to be the height of the bar. All right, so that's just x is your categorical variable, y is your numeric variable, geom_col for columns, and you know, for the slide they use theme line draw, so it's easier for you guys to see. But
is the theme line draw the lines behind that?
The theme line draw is, yeah, it draws the tick marks in a solid line versus gray. Probably for most of you, I would recommend theme_BW for black and white. BW probably, in my opinion, looks better, but with this projector that kind of washes everything out, it's a little bit harder to see. So
theme BW makes a plot as well, but it's
it just changes the kind of the color scheme, and there's like dark themes and gray theme. You know, it's like, yeah, on your browser you're familiar with dark theme and light theme, right? And it's kind of like that. It's just what colors are we using by default?
Sorry, what did we put in between the brackets of geom_col?
I didn't put anything inside geom_col.
Are we supposed to put something?
You don't have to. You can. Like if you wanted to change certain settings and stuff, you can. But for now, just your basic bar plot or column plot, you put, you know, probably your categorical variable on x and the numeric variable on y.
Okay, thank you.
Okay, so here are some settings that you can put inside geom_col if you wanted to. Okay, and so one is you could change the color. So by default, it uses kind of this gray. It looks kind of black on the screen, but it's like a dark gray. But you can change the color if you wanted to, right? And these are settings. I haven't mapped them to variables, but if you wanted to, they could be mapped to variables, right? So we could map the fill color to a variable. Color should probably get mapped to, well, it could be categorical or numeric, okay? So the fill color, you could also change the outline color. Okay, so the outline color is color, all right? I don't know how much I would recommend changing the outline color, but it can be done, okay? And then you can also, if you do make use of the different colors, you can change the line width, okay? So the line width, currently I have set to 2. You can, you know, make it big, like 5, or I think default is 1, or it's something thinner, okay? So these are different aesthetics that can be mapped to the column object or set if you wanted to change the way it appears. You can also adjust the width of the bars. All right. So this is the default bar width. Okay. The default bar width has a value of 0.9. If you want to, you can make it wider. Okay. and the max value was 1, and that means the bars will be touching each other. Okay, so if you do 1, the bars are touching each other, and there's no kind of gaps. Do you put gaps between the bars in a bar plot? There's no rule. Probably we recommend to kind of indicate that they're distinct. Versus say a histogram, you don't put gaps between the bars. I mean, I guess you could, but I think it could throw some people off. But yeah, so bar plot, generally you leave gaps. Histograms you don't, but again, it's an option, and so you could change the width. You could even map a variable to the width of a bar. I don't know if I would recommend it, but it is something that can be mapped, right? So perhaps there's another numeric variable, like a secondary numeric variable, and you want to kind of emphasize its size by mapping it to the width of the bar. And so fat bars are like the high in that numeric variable, and thinner bars mean something else. Good job. Okay, and so anyway, here's width is 0.5, width is 1, and you can imagine however you want there. Yeah, question.
What's the difference between a histogram and a bar graph?
So a histogram is you have a numeric variable across the bottom. You cannot rearrange bars. Okay.
Right.
With a bar plot, you have this categorical variable across the bottom, and the ordering of the bars is arbitrary. Okay? With a histogram, it's tied to the number line. You can't decide one day I want to put the number 5 to the right of the number 10. Okay? With this, here I have it in control, treatment 1, treatment 2. If we want to go treatment 1, treatment 2, control, that's also allowed. You would arrange so the default is it goes in alphabetical order. Okay, that's kind of the default, but you could rearrange it in other ways. I have examples of how it's being rearranged. You could arrange it by another variable. You can create a factor. I think in one of the data camp homeworks you created a factor, and then there's also I didn't assign the chapter on factors, but you can also go to data camp, and I think in Introduction to R, one of the chapters in that course is on factors, and it talks about how do you set the levels so the levels are in the order that you want, okay, rather than alphabetical. Yeah.
About the data camp, will we have data camp homework throughout the course, or is it just because the ones that are assigned just end this Friday? Right.
I will probably assign a couple chapters each week, probably through the first 6-7 weeks or so. Okay. The last couple weeks, I probably won't be assigning. I want you guys working on your final projects and group projects and stuff. Okay. I guess just in the back of your mind, start thinking about who you might want to team up with for groups of 4. Groups of 4 for your group projects, your final projects. Okay. Maybe one of the days I'll set aside some class time to kind of mingle, so you can kind of establish a group, and then I'll have an online thing, and if mingling and talking to strangers is something you don't want to do, then we can just have I'll give you the option that if you want me to assign you to a group at random, you can opt into that, right?
It's college.
Yeah, well, I mean, it's kind of like if you have a group you want to work with, great, and that's what I imagine most. But then some people, for whatever reason, maybe can't come to class, maybe don't know anybody else, and so if you want me to assign you to a group, I can assign you to a group too.
Does it split evenly?
They're probably not going to split evenly. We might have one group of 3 or one group of 5 or something like that. Maybe 2 groups of 3. We'll figure something out, okay? But I guess there's also a possibility that someone signed up and registered in the class, but like just hasn't shown up and doesn't do anything, and I'll reach out to that student individually, and I don't want to assign that person to a group either. I feel like 4 is about the appropriate size where if someone doesn't contribute, it's very clear, and versus like if you have a group of 5 or 6, it's easy for someone to kind of not do anything and the group will survive just fine. If it's 4 and someone doesn't do their part, then it'll become obvious, and then talk to me. All right.
When should we have this group figured out?
I'll make it.
Announcement.
I'll make announcements, and I'll assign like assignments on Canvas to kind of tell me what your groups are and stuff.
Sounds good.
Okay. All right. Bar plots. You can have like a second categorical variable. I mean, you can have more than 2 categorical variables going on with a bar plot, but it's hard to illustrate too much. So anyway, in this case, you'll take your numeric variable, you'll map it to y, and then you'll map one of your categorical variables to x, and then you'll probably map the other categorical variable to the fill color, right? And there's a few options, positioning options. One is to dodge them, which means they go side by side. You can stack them, and you can stack them proportionally. And so they're called dodge, stack, and fill. And you'll see all of these examples. And so here's the data set that I'm working with. And I have 2 kind of categorical variables and 1 numeric variable. And so this is, I guess, imagine a store where you have different kind of sales teams. Okay, and you've got team A and you've got team B, and the question is like, okay, which team performs better? They had sales. I guess they ran them on Wednesday, Friday, and Saturday, and these are kind of the different sales figures for those different days. And so the question is which team does better? Is team A the better team? Is team B the better team? Which days of the week do they get more sales and stuff like that? So when you look at these plots, what I want you to think about is which plots and which mappings of variables kind of draw more attention to the difference between the days, which ones draw more attention to the difference between the teams. And it's a little bit subjective because all of these plots all present pretty much the same exact information, okay? So at least with dodge and stack, remember, part of the visualization is going from the data into a visual, and the other part is going from the visual back to the data. And then, at least for dodge and stack, you could recreate this entire data set and completely if you needed to. But the question is, when you look at it visually, what do we notice first? Okay, yeah.
Just a slight syntax question. So
Yeah.
when you assign that data frame to the df variable, could you have used the equal sign as opposed to?
I could have used the equal sign.
Is it good practice to use that?
The traditional assignment method in R is this arrow, but R does accept equal sign.
Is it on the bottom when you?
So yeah, within,
When that vector is assigned to team, you use.
Yeah, so within the data frame, when you're giving variable names or column names, you use the equal sign. But so the arrow here is kind of like assignment at the top level. You don't use the arrow assignment inside the data frame.
But
so
it would work. Technically, they're interchangeable.
No, they're not.
Oh,
so you have to use equal signs inside here. But up here, like when because you're basically setting, like within a function, and you're setting argument values, like you use equal signs, okay? You don't use arrow signs here, okay?
Right.
But if you wanted to store the output of the function into an object, you use the arrow, okay? But you can use the equal for assigning at the very top. It's also allowed, but the traditional assignment is the arrow. Yeah, either one of you.
What did factor do?
What does the factor do? So If I just had C Wednesday, Friday, Saturday, and stuff like that, it would be a character vector, which is fine. But then when I create my plot, the default is it's going to put these in alphabetical order. Okay, so it would go Friday, Saturday, Wednesday. Okay, which is not wrong, but when we think of days of the week, there's kind of a natural ordering, right? Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. I mean, I don't know why. I mean, that's just like the order that we've accepted. And so here, to kind of set the order, I create this I turn the character vector into a factor, and then I specify the levels to go into this order: Wednesday, Friday, and Saturday, right? And if I wanted to, I could do all 7 days of the week, and I could put them in the order that I want. But by default, it would go alphabetical. I don't want alphabetical for days of the week, so I'm doing this. Yes.
If we're gonna be reusing the same the same things inside, for the team, for example.
Okay.
Different things would be able to just define it once outside and then just use it inside as.
You could. You can define vectors outside and then set them inside the when you create your data frame.
When that's done, would we use an equal sign outside as well, or the arrow?
Again, so when you're storing the data frame, the object itself, you would generally use the arrow, okay? But inside a function, right? So data.frame as a function is a function that creates data frames. And so within a function, you don't use the arrow, you use equal signs. Yeah, more questions.
What is the levels?
The levels puts the order. So again, this is a character vector. If I didn't use the levels here, it would default to putting, like when I arrange these. So down here, the date or day, I have Wednesday, Friday, Saturday, which kind of makes sense because there's a natural ordering for the days of the week, okay, or at least a conventional ordering, I should say. I don't know about a natural, but a conventional ordering. And if I didn't specify that, then Ggplot would arrange them alphabetically, and it would go Friday, Saturday, Wednesday, okay? And the entire days of the week, I don't know, Sunday, Monday, Tuesday, Wednesday, Thursday, Friday. So it'd be Friday, Monday, Saturday, Sunday,
You said it's a
Thursday,
position
Tuesday,
or dodge? Yeah,
something,
makes sense.
Wednesday, huh? This is position dodge, puts the bars side by side, the different colors. Yeah, question.
So factor and the level thing does the same thing.
No. So factor is wrapped around the character vector. Okay. So this is a character vector. So up here, A and B, team A and team B, I just left as a character vector, and the default ordering is alphabetical, and that's fine. A comes first, and then B comes next. Okay, that's fine. If I just left it here, it would have put them in alphabetical order, and it would have gone Friday, Saturday, Wednesday, which is weird. I wanted to specify the order, so I wrap the character vector inside a function called factor. Inside the function factor, there's an option that says, what order do you want these different levels to be in? And the order that I want is Wednesday, Friday, Saturday. Yes.
Would you ever use the factor function without levels?
If you're okay with the default alphabetical ordering, and in that case, it's kind of like, well, why didn't you just leave it as a character vector? One thing is that if you do wrap a thing in as a factor later on, and you wanted to add something, okay, to a character vector, it will just let you add any characters that you want. If I want to add team C or team D, that's fine. If you define a factor, okay, then it's going to look through the initial character vector and say, okay, I see 3 unique values. These will now be the only 3 unique values that are allowed. So if I tried to add K as a day, it's going to reject it. If I try to add Thursday as a day, it's going to reject it. Unless here, even if I only have 3 levels, I could write 3 unique values here. And levels, I could specify all 7 days of the week, and then later I can add things. And then so the factor kind of has this check that says only certain things are allowed, whereas the character vector just says anything goes. Okay, so I don't know, it's kind of like if you ever had a form where people fill out like their birthdays and stuff, okay? And you say like, what month were you born? And some people might write numbers, some people might write, August, some people might write AUG, okay? And basically a factor kind of just says, only certain values are accepted, typically. Okay, so anyway, this is, you do position equals Dodge, and this creates kind of side-by-side bar plots. And so, we can see Wednesday 240 for team A, Wednesday 200 for team B, right? 240, 200, and this one is, and if you had to recreate, what number is this? Friday team A is 290, Friday team B is 260, something like that. Okay, 290, 260 indeed. And then over here, Saturday team A is 300, Saturday team B is just a little bit higher. Maybe we don't know exactly, but we could, 305 is the actual value here. So if we had to go back and forth, we can, right? That's an important part of the data visualization. Okay, so that's side by side, that's position Dodge. And this is where I have date onto the X, and I have the fill color, the team, mapped to the fill color. Okay, same information, but this time I have the team mapped to the X, and I have the date mapped to the fill color. Okay, so I have Wednesday, Friday, Saturday here. These two plots present the exact same information. If we needed to recreate our matrix of data frame back here, both of these will produce the exact same information. The question is, what do you guys think? Which one draws more emphasis? Like if we wanted to kind of make the point that team A is overall sells more than team B, or if we wanted to make the point that we have the most sales on Saturday and the least sales on Wednesday, both of these kind of communicate that, but I don't know which ones do show you a little bit more successfully that difference, okay? And it might also just be a matter of opinion, right? Some of you might just say, like, I like 3 colors. Like, I want 3 colors, okay? And that's fine, okay? But there is a difference. Like, at initial glance, these things kind of feel very different, but it's the exact same information underneath, okay? The next 2 plots also, exact same information, but they also feel very different. So here they are, we're stacking them, okay? Stacked, if I said, okay, well, how much did team B have on Wednesday? 200. How much did team A have on Wednesday? Another 240, okay? And so the total stack has a height of 440, right? How much did team B have? This is 230, and then, now it's a little bit more complicated. But it's stacked on top, and if you had to like pull out your ruler, you could recover that number. And similarly, we have this, right? 300 and 305 or something for these 2 values. Okay, so this is you have them stacked on top of each other. Same thing, except this time I mapped the day to the fill color and the team to the x-axis. And so now we have 2 positions on the x-axis. We have team A and team B over here, and then we have Wednesday, Friday, and Saturday stacked up like this. So this is...
It's like a pride flag.
Huh?
Like a pride flag.
Yeah, they're very different. And how do you want it presented? Okay, and what's more effective? I don't know. Okay, so these are questions that you should be thinking about, and that's going to determine where you map each of your variables and whether you're using position dodge or position stack. Okay, sometimes you want to emphasize like out of 100%, this percentage was A and this percentage was B or something like that. So in this case, you do position equals fill. Position equals fill. Okay, and
on a project, if we made a graph,
yeah,
would not. Could our points be based on how well we present the data?
So
it should, right?
Yeah. So during the project, so the way the project works is, you do this kind of data analysis thing, and you create a report, and I'm going to schedule basically these 1-hour sessions with every single group. So there's going to be like 20 groups, And it takes a long time. But I schedule 1 hour with every group. The group presents for about 5 or 7 minutes, and then I read through the report and I ask questions about pretty much all the decisions that you've made during the remaining hour. Maybe I should say 50 minutes. And yeah, if I probably won't take points off. Like if you choose this and I thought this would be better, I'm not, that's fine, okay? However, if you present the information poorly, all right? And so like next week we'll talk about creating summaries or I don't know, maybe tomorrow, I don't know, like grouping your, group by and summarize. And if you do that kind of incorrectly, then yes, I will deduct points. And depending on how severe of a mistake it is, I might, deduct, a significantly harsh penalty. I'll try to show you some examples of like bad plots, right? I'll also give you examples of like good reports. So you have kind of like, something that, here's an example of an A report. And here are examples of certain mistakes that students made or other groups made that resulted in penalties and stuff. Okay.
If you wanted to change the title of the index where like it says teams or date, like for example, if you wanted to say like the index, the legend right there, if you wanted to change the title of that, is there a function for that? Yeah,
you can customize pretty much everything here. There's default settings, which I think makes sense based on the data inside your data frame.
Sometimes it's like lowercase, and like I want to switch it to up.
Okay, yeah, we can talk about all of that stuff later. Okay, but stacked, and so this is here. It is stacked. So again, depending on which variable you map to the x-axis, you'll get either 2 columns or 3 columns or however many things you have, and this is what it looks like. So again, keep in mind what you want to present and how it looks. Oh, you know what? Let me give you your review quiz answer, but I have to look up what the answer is because I don't remember these things. Okay, week 2, Wednesday. Your first answer is the letter D. D as in dog. D as in dog is the first quiz answer. Okay. Here is just a tiny bit of code for another example. So there's a data set called US population change, and it went from the year 2000 to the year 2010, and it just says, how much what percentage did the population of the state grow, right? So some states grew. I don't know if any states shrunk between 2000 and 2010, but certainly some states, their amount of growth was a lot less. Okay. And so basically what this is doing is it's going to arrange the order of the rows, okay? Because I think it started off in alphabetical order, but here we're going to say we want to arrange by this column change, and we want to put it in descending order, right? And I think you probably saw an example of something like this in your data camp homework or something like that. And then here we're just gonna look at the top 10. So I did slice 1 through 10, and so that's just gonna kind of save the first 10 rows, right? U.S. population change, arrange in descending order by change, and slice the first 10 rows. And then there's a few columns. Okay, one is the state name, one is its postal abbreviation, two-letter abbreviation. And then the region, and I don't know which regions, probably the West, and then the South, and I don't know, East, Northeast. I don't know how many regions exist, but here they kind of just defined a few as West and South, and and that's what we have, okay? And here's the values, right? And so we have Nevada having the most population growth between 2000 and 2010 with a growth of 35%. Arizona also grew a lot, 24.6%. Utah grew 23.8%. And, you know, all of these other states grew different amounts as well. Okay, and so here, here I said, okay, let's put the abbreviation along the x-axis. And so it does it in alphabetical order, you know, AZ, CO, FL, GA, and stuff like that. And, you know, if you're from the US, you can probably read these just fine. And if you're not from the US, you know, it might be a little bit tougher. You know, SC is South Carolina and stuff like that. Okay, and then the height of the bar is the change, which is what we have. Okay, and then here I decided to color in the using the region. So west is in blue and south is in red and things like that. Okay, geom columns and theme line draw. That's what we have here. If we wanted to, we can map the fill color to the numeric variable. Okay, numeric variable change. And so, so now there's no region information. And here we're just presenting the same information twice, kind of maybe to draw emphasis to the differences here, okay? And so the tallest bar is also the lightest, and the shortest bar is also the darkest, okay? Because both of these variables, the color and the height of the bar, both represent this, this variable change, yes?
What would happen if in between geom column and parentheses you would put position equals to dodge?
So with position equal to dodge, we don't have any, quote, overlap between these two variables, in that if there was position dodge would work if we had Arizona South and Arizona West, if that makes sense, right? So in this data set, if I had one row for Arizona West had a certain value and another Arizona South had another value, then they would either show up stacked on top of each other or dodged against each other. But in this case, there's only one Arizona, and it's west, and there's not an Arizona South that I have to kind of plot. So position dodge wouldn't make a difference here. Okay, so again, the default order when you use something like a character vector, all right, is to put it in alphabetical order. Again, one way to have manual control is you can turn it into a factor where you specify the levels and you put it in the order that you want. Okay. Another way is you could order the values based on another variable. And so in this case, I'm ordering them in order of change, okay, from least to greatest. So I'm doing X. So it used to be X is equal to the abbreviation. We're using the state abbreviation to order the values, okay, or not order the values, to put them on the x-axis. We still want the state abbreviation on the x-axis. So X is still, we're going to have ABB for the abbreviation, but I want them arranged by order of change. So I'm going to do X is equal to reorder those abbreviations based on what variable? Based on the variable change, okay? And if you want to, you can do descending change or something like that, all right? And so this puts them in order. And, you know, by leaving fill color also equal to change, this really emphasizes kind of this from dark to light in terms of the color. And so this really does just has the same information, and we don't have any information about the regions. But perhaps you really want to emphasize these differences, and so you might map two aesthetic attributes to the same variable, and it really draws your attention to that kind of aspect, right? Which might be something you want to do, okay? If you want custom colors, you can do custom colors, and I think I tried to look up like UCLA's palette, and again, our projector kind of throws off the colors. It looks a little bit better when you open up the PDF on your laptops or something. But here, we want to when we did fill color is equal to region, okay, we can say, well, I want to control how that fill color is adjusted, right? So the default is, this, whatever these two colors we call them, okay, red and blue-ish. And here you can say, well, I want to control the fill, right? And so I can do scale fill manual, and the two values I want to use, and you can give it, you can give it named colors like red and yellow, or you can also give it hex values, which if you've ever done kind of like CSS and stuff, like you're familiar with hex values. And if this code means nothing to you, don't worry about it, okay? You can just go on colors and hex values, or color hex value, and probably whatever. All right. Oh gosh. We'll accept the cookies, whatever. Okay. And so you have your color palette, and they all kind of come with different hex codes, and there's a bunch of stuff out there. Okay. There's like probably 50 websites that will help you figure out the hex colors for the colors you want. Yeah.
How does it know which color to assign to which?
Again, default order is alphabetical. So this one will be the first one, will be for south, and this one will be for the other
because
one.
of the number, like 3 is in front of like the letter F, so they.
No. So this one goes for. Remember, so the two regions are south and west.
Yeah.
So alphabetical is south, then west. So this one gets assigned to south. This one gets assigned to west. Okay.
Yeah.
Okay. So that's scale fill manual. As far as you can also change it, and if you wanted, like, so here we did a numeric variable for the fill color, and so. The default is kind of like from dark blue to light blue, okay? And here you can say, well, you know what? I want a different gradient, okay? And here the gradient, you can specify how the gradient works. And you can say on the low side I want red, and on the high side I want blue. And this actually draws quite a bit of attention to kind of the, how drastic of a jump it goes from here to here, right? Like I would have expected more kind of purples in the middle, but no, actually it kind of makes sense because there's nothing in between here and here. It just goes, straight from like 24 to 35, and so we lose kind of a lot of these in between values here, and also the projector turned a lot of these things like into the same shade of red, but yeah, that's something to keep in mind, right? I mean, here I keep blaming so many things on the projector, but you have to think, okay, well, what if, the thing I'm showing is going to be printed in black and white, okay? Keep that in mind, all right? Obviously, color isn't going to be as useful, yeah.
Do these values also accept the hex code?
Yes. So, yeah, anytime you give it colors, all right, and you want to kind of specify colors, you can give hex codes, you can give it named colors. And there's a list of named colors, and you just have to go to like R named colors and search for it, right? Because there's light blue, and there's like chocolate, and there's I don't know. There's a whole bunch of weird color names, right? And other color name, like what color is like ochre? That's like a color, right? And taupe and mauve and fuchsia, and
These colors?
These are names of colors that I don't even know, right? Like, but I don't know, right? What is the color taupe? What is this, right? So this is and then it's something like this, okay? And ochre is something like this.
Whoa.
Okay. All right. So, but yeah, I don't know what colors are named, right? So a lot of times it's easier to kind of specify a hex value if you're going for something that's not like red, orange, yellow, green, or blue. Okay. Oh gosh, all right. 5 more minutes. Okay, let me give you your second and third view quiz answers, which are the letters C and E. C as in cat is your second answer. C as in cat. E as in elephant is your third view quiz answer. So the second one is C as in cat. The third one is E as in elephant. Okay, C and E. Okay, bar plots are also useful. So in all of these other cases, we had the height of the bar was one of the columns, right? So the height of the bar was this column change. A lot of times you want to use bar plots if you just have categorical variables and you need to like count them, okay? So you want to like, so a lot of times you might have a categorical variable and you want to say, okay, well count how many of these things I have, and then you use the bar plot. The height of the bar represents the count of that thing. So here's an example of this very big data set, diamonds. It's got 53,000 rows in it, okay, or almost 54,000 rows. And basically, I guess they gathered a whole bunch of diamonds. I don't know, you go to some diamond company mine or something, and you know, they cut the diamond industry is like a weird thing. And you know, you look at this rock and they say, okay, well, how big is it, right? That's the carat, and that's going to be a numeric thing, okay? But then also like the person who cut it, did they do a good job? And there's like the ideal cut and a good cut and a fair cut and a very good, and they get graded. There's also like somebody, they look at the diamond, they look at the color, and basically you want like this colorless diamond if it's like clear, but then like in some cases it's like kind of yellowish, and that's less desirable. Okay, and so you get color grades anywhere, I think, from D to, I don't know, J or something. Okay, clarity, you know, they again look at it with this little magnifying glass, and if there's like any specks of impurities in there, you know, the clarity grades goes down instead. Okay, so but anyway, I've got almost 54,000 of these rows. And right now I don't have like exactly how many ideal E color diamonds do I have? How many premium E color diamonds do I have? How many good E color diamonds do I have? I have to kind of go through and count them. Now, thankfully, I don't have to do this with 54,000 rows. We can ask the computer to do it, right? And so if you just say, notice I only have one variable mapped to the x-axis, okay? I didn't map anything to the y-axis. And instead of geom column, I say geom bar. So geom bar is going to say, all right, kind of the default setting is we're going to figure out the counts, and we're going to do the height, or the y will be the counts. So here I said, okay, well, how many fair cut diamonds are there? And it goes through and it counts them all. How many good cut diamonds are there? And how many ideal cut diamonds? So, you know, usually the diamond cutters are pretty good at their job, and so they're able to pull off ideal cuts a lot of the time. Sometimes they, you know, intentionally go for maybe a less of a cut, because less ideal cut, because maybe the diamond is shaped a tiny bit funny, and in order to kind of increase the carat size, you know, maybe like the perfect shape, you know, has like this angle, but because the diamond is shaped a little bit funnier, they take a slightly wider angle or something, and then that takes the diamond cut down, but you know, maybe the carat size goes up and they can make more money off the diamond. So, but anyway, this is how you do it, right? Notice only one variable is mapped, and I have it mapped to the x-axis, and then the height is automatically figured out using the count. Now, if you want to, you can also map. You can take a second variable like the color, okay? And again, you could take any kind of categorical variable and you can map it to, say, the fill color here, okay? So here I have the cut. Cut is categorical, color is categorical, and I have this geom bar. The default position is stacked, and so we get these stacks here. And again, you can specify your colors manually if you wanted to. This is kind of your the default palette, color grade palette. Here, what's the difference? Here I have the position is stacked. Over here I have position dodge, okay? So rather than having 1, 2, 3, 4, 5, I guess there's 7 colors stacked on top of each other, I have 7 things side by side each other, okay? And this kind of emphasizes a little bit more how I guess the G color is, you know, probably the most common in each of these things, right? E, F, G, those are the most common colors. You don't encounter J colors very often, and so on. Okay, and we also see. So again, you know, what's the difference? You know, this is what we see, and you can also see, you know, the total is like 20-something thousand, and here, you know, that it's each individually. So if we were to add each of these things up in total, we would get something close to 20,000. But here we have this. Okay, this is position fill, so that proportionally they all go up to 100%. So we lose the fact that there's way more ideal than fair. So you lose that, but you see proportionally, this is kind of what you get. Okay, and here I changed the mapping. I put color on X, so now I have 7 positions along the X, and then I did cut as the fill, and this is what we got there. Okay, all right. I guess that's it. I've added this stuff for line graphs. You might have to just look at it on your own. There's only a couple things. There's only a couple aesthetic attributes to point out here. Yes. What's on Canvas isn't loading? This isn't loading? The PDF on.
It didn't load for me. I don't know if it's the Wi-Fi or.
No, I
Okay.
downloaded
All right.
it.
I'll re-upload. Okay.
Good.